It's that. Okay, welcome back. So from a contest whose name was very creatively called Extremely Obvious Olympiad Questions, where extremely is missing the starting E and questions is for some reason spelled with a K W instead of QU. Um, a pinwheel is three equally spaced sec rays, and the problem is, given 3 points, can you always, is it always true that you can find a pinwheel that separates them into n groups? Three n points, you want to split it into 3 groups. Okay. Can I just make the points collinear? So no, that's sorry, it doesn't work. I'm stupid. Never mind. For some reason, I thought like the center of the pinwheel was fixed. But yeah, sorry, this just doesn't work. Never mind. But okay, like the fact that like it's easy to describe how a pinwheel hits a line, which is why I was thinking of that. Like if you have a line, you know, if I have you know that like the it has to be like that. Ish. Wait a minute. Hang on. No. Wait, what am I talking about? What am I smoking? If I have a pinwheel shape. Yeah, oh, okay. Pinwheels are rays. Fine. I guess like a straight line always hits in like 2 of the rays. You can't hit all 3. So I want to modify this by maybe just a little bit. Yeah. Yeah, I wonder if I can like stack. A line is defined as a set of 2 rays. You can, yeah, dividing line I know how to do. Undergrad theorem, which is similar. What, like the ham sandwich thing? I don't remember what the ham sandwich theorem says, though. I just remember the name. It feels like there's going to be some sort of construction. Like, yes, if you... Yeah, I like... Even though the, like, putting them all on one line doesn't work, I like the idea just in general of having, like, a lot of them on one line just because it's so easy to control. Like, what if I put, like... Like, suppose I put, like, n-1 points here and, like... well, let's do, like, n+1 and n+1. Or something like this, right? Then what that means is my pinwheel has to, there has to be a cut here somewhere, because if there's no... Or not, like, sorry, what am I talking about? Let's say this is n+1. And then this is... This is also n+1. And then this is the, I don't know. You just put some more things on. Well, it's like, I want most of the things to be on this line. So let's make this like n minus like, 4 or something. Let's do n-3 for now. And then you have like 1 point that's like not. Like, okay, so this, I guess this is a picture when n equals 4, in which case this is freaking. God, it's so hard to draw a line. The line's so bad that it didn't get rendered as a straight line. Okay, so there's like at most 1 point off the line is the thing I'm trying to get at. And then in that case, like no matter what, the pinwheel has to cut like there's like either. Alright, let me get this right. It's like this very narrow interval here. It has to cut this interval because there's at most 1 point off the line. And so when you count the number of things in a sector, if you look at the intersection of a pinwheel with this purple line, like there's at most 1 point off it. So what that means is that, you know, either it's like these n-1 and then the one that's off, or it has to cut like the here and here's n and the last point is somewhere else. Because otherwise if you cut, you can't have, there has to be cut somewhere in here, and if you cut too far to the left, then it doesn't add up to n, because all the points will be missing. So there has to be a cut here, and then similarly there has to be a cut here, and then I can stick like n-3 points, doesn't matter. So that already constrains the pinwheel, because what it means is that I need to pick like a point in some very narrow interval, some other point in some narrow interval, and then the angle between them has to be exactly 120 degrees. So the center of the pinwheel necessarily has to lie in I don't know how to do the geo. Like some circular arc like thing, right? Like something like this and then that. I don't know exactly what to measure, and like the reflection on the other side. Do you think the answer is yes or no? I'm not sure yet. I'm still leaning no. Because collinearity. Like, I feel like collinearity places a lot of constraints. Or, well, I don't know. I'm not sure. I'm just trying to like see like if I have this line that's like this, then it's like already it's this like pretty narrow-ish strip. But then I have one extra point and I should be able to... I almost want to say I can wedge the point somewhere that it will be annoying. Maybe... I'm not sure, actually. No, actually, I don't think there's a place I can put the last point to force it. Shit. Actually, this is too close to the all collinear case. Yeah, the problem is like no matter where the point is, I just fudge the yeah, you can always fudge it. Oh shit. Oh, actually, can you? Yeah. I don't have a good visual sense of like... I put a pinwheel here and then this last one. Ah, yeah, that's annoying. Are you guys having that much difficulty judging whether the solutions are correct? That's not a good sign, actually. If the answer was yes, what would the proof strategy look like? So I can do like the dividing line case, because what you do is you take projection, and then what you would want is so I wonder if you could do something like the following. So you have your points. You orient them such that the you orient them so you don't have to worry about stupid collinearity stuff. And then well, okay, you could like find for any orientation, I can take a line that like cuts a third of them exactly. Right. So this is a thing I can do. That part says take a rotation such that none of the yada yada, and then take the orthon, and then okay. Yeah, but the problem is then I want to like I don't the fact that the angles have to be exactly 120 degrees seems to pose some issues. Okay, here's a different thought. Take the set again, take some direction, and then take a. I'll just take something that looks like this. All right, and the idea is I want to. What do you mean the angles don't matter? What? Why don't the angles matter? Oh. Wait, really? Wait. But okay, like I actually know how to do the problem if it's like 180, 90, 90, I think, right? Because you do the 1/3 thing that I said here, and then you do another project and then bisect. So I can do it if the y is replaced by a t. So if you're telling me the angles don't matter, then like does the t argument just work for a y as well with suitable modification? IDK, find out. Well, if the result is the same regardless of the angles, that tells me that the answer is yes, because this is a like clean proof. Like this is a proof that it's yes. So in that case, I want to be doing something similar here. Well, the reason 90/90/180 works so well is that hey, thanks for the yeah. Anyways, no, it's just incomplete username accidentally gave a much bigger hint than he meant to. Because I know how to do it if I know how to do the problem if the angles are 90/90/180. So if the yeah. Okay, that's fine. Isn't that case trivial? Yeah, that's the point. Like, it gives away that, it gives the yes-no part of the problem away, because if the answer doesn't depend on the angles, and I know how to do the trivial case, then that tells me what the answer is for the main case. Okay, that's good to know. Yeah. Okay, well, now I can stop looking for these cursed counter examples. But see, honestly, I was hoping the answer would be no, so that the write-up would not be too annoying. Like, if the answer is yes, then you have to use some sort of, like, intermediate continuity type thing. If the answer was no, then you get to have a bit more fun with, like, okay, as long as I find any construction, you know, it's a-okay. But if it's possible, then I have to just suck that up and deal with the continuity. Okay, anyways, take a dividing line, and then imagine you have a y, and then, I guess what you do is you move it upwards, and then you can also move left to right if you need to. I think. Or some, oh god. I just don't want to do, Like one shape of argument you might imagine is something like the following. Like you pick like this blue line, and then you lift it up until you fix this blue line, and you lift things up until like eventually your thing has like n in here, and then when that happens, you'll have like some number here and then some other number here. And what you're hoping is that those two numbers will also be equal. But then you have one other parameter that you can play with, which is like you can say like for we'll pretend like this is x-axis or something, right? You can let like f of x be defined as like the first number minus the second number. And you want it to be 0, but it should vary like quote-unquote continuously for some definition of continuous. And then if it's like, so if it's ever positive and one way and negative the other way, then you're all good. There's something else you can do to make the pinwheel nicer. What? You have 3 degrees of freedom for an output space with 2 degrees of freedom. Well, I don't know, man. Well, okay, I mean, this thing I'm doing does throw away degree of freedom. I'm like tossing the rotation. Yeah, this thing that I wrote down tosses away the rotation ability. Like it lets you, it fixes the orientation of the pinwheel. But I don't know. Degrees of freedom feels a little weird to me to say here because one of the outputs is a discrete space, so it doesn't really have a dimension that's behaved the way you normally. Like there's 2 constraints, but both constraints are like discrete constraints. So it's not as cut and dry as with like continuous versions where you really have a strong statement. I don't know. Yeah, I mean, that's almost what I'm doing here. It's almost like, actually, what I'm doing here I think basically amounts to fixing the orientation and then looking x and y. Fix a nice orientation. I mean, what, do you just want me to pick one for which, like, none of the directions are parallel to any line through 2 things? I can do that. And then you let x and y. It's like, now I have like this 2 variable discrete continuity result, which I'm not a huge fan, but. Does that actually just work? Ugh. I mean, this is what I have written down on the board, right? Like, this is what I'm doing. I just have it in terms of x and y coordinates. Maybe I shouldn't be using x and y, and I should be using like, oh, I see. I shouldn't use x and y. There's no reason to use x and y. I should use x in like a different direction. Because that way, I see. I should be using a non-xy basis. Okay, I understood. So let's just fix this pinwheel orientation, and then we use like this as our x coordinate and this is our y coordinate. And then you know, there's a function from positions of the origin O to triples ABC such that A plus B plus C equals, well, let's call this one like A, B, C is equal to 3n. And you can, by zooming out the picture, I can get this function hits each of 3n 0 0, 0 3n 0, and 0 0 3n. Also, when I move in the x direction, the only changes that can happen over time are like in the x direction, like you can run into situations where C decreases and then B increases, or A decreases and B increases, and then, or vice versa. And in the y direction, it's similar. So then what? Thank you, Newbie P, for the follow. Yeah, it's like C++. Honestly, I can actually just have 3 vectors. It's fine. Guys, what if I use barocentric coordinates? Can you force things to become nicer in a way? Okay, guys, I have a bad idea. You want to hear a bad idea? So, enclose all the points in a big equilateral triangle. So, and then we're going to consider, as was suggested, we're going to consider fixed orientations. So here's the thing, alright? It looks like this. So if I put the origin at either of these end points, then, you know, all of them are in one region. So now, now for every, we're gonna make like some integer-ish lattice or some bullshit where I don't know, just do this. And for every point I color it based on which of the three sectors. Like in this fixed orientation, if I call this 1, 2, 3, and I always avoid, you know, bad points, I can assign each point a color according to which sector has the most points. And then we use Sperner lemma. Which says that because it has the property that like this point is always colored 3, this point's always colored 1, this point's colored 2, everything on this line is colored 3, 1, 3, 2, 1, 2, and then so on. Then there should be like, no matter, I can find a sufficiently fine triangle in here such that the colors are all different. And I think if I do that with like a sufficiently fine mesh, you can take a point inside there. I think this should work. I'm not 100%, but I think something like this should work. Yeah. The coloring argument is that, like, you pick whichever one has the largest number of points. I mean, with ties split arbitrarily. And I don't know, it shouldn't matter, it's just, like, in a transition, I want to say that, like, if you take a sufficiently fine mesh such that things are, like, constant, or I don't know. I have to think this through, but I feel like this should do what I want. Oh. Actually, okay. I take back what I said. I think the tie breaking should be not arbitrary. It should be done in like some fixed order, where like if 1 and 2 are tied, you pick 1, and if 2 and 3 are tied for first, you pick 2. You pick like the smaller number if it's tied, and then yeah, you take any triangle that's numbered 1, 2, 3. And if you pick the mesh fine enough, where your transitions, there's at most one transition between every like edge of the mesh, then this 3 should work, because you're told that when you shift it a little bit, yeah, do you want to write this up for me? Because I don't really want to write it. Hello, David Kim. Yeah, okay, this is... Well, I will attempt to write this up and make sure... I don't know. Discrete continuity or something. Suck. 2023. Actually, we can let it be a calligraphic S. The answer is yes. So contain all the points inside a large equilateral triangle whose orientation is such that no two of the n choose 2 points differ. So no line through any 2 points of S okay, let me just rotate the plane such that no line through any 2 points has an argument whose argument is a rational number of degrees. Then contain all the points in a large equilateral triangle as shown below. Let n be a large positive integer and divide the triangle into a mesh. We are going to commit to taking a pinwheel upwards facing as shown below. We're going to commit to taking a pinwheel whose arguments raise point in the 90 degrees, 210 degrees, 330 degree directions. Okay, so then I have to actually drill this stupid thing. Dot I don't actually I'm not 100% confident in the Sperner thing, but it has the right feeling, I think. We're gonna find out real soon whether I'm gonna be so sad if this doesn't work though. Oh shit, I didn't define the points that I need. Oh my god, I'm so bad at this. How did I do that? I wanted an equilateral triangle mesh. Oh shit, this should be here. Hello, Fractical. Wait, do I just suck at implementing barycentric coordinates? Oh shit, it's u plus v. Ah. Okay, I want to add a diagram like 7, 0.4 times pinwheel. Label W plus dir. Okay, so 210, 150. Now, okay. Centered at one of the n. Oh, Shiba. Okay. The typing and converting type of it. This is Vim. Is the editor? It's just Vim. Oh, the editor is Vim. It's LaTeX underneath. I mean, you can see it's LaTeX. Asymptote is doing the figures. As we consider moving the pinwheel across consecutive points in the lattice, we get X, Y, Z. We color every point in the lattice. Well, let me say we label with the name of the region with the most points. These numbers change as we move the pinwheel. But if we pick n large enough, we can ensure that at most one point moves between regions as we perturb the pinwheel. We now label every point in the lattice with the name of the region with the most points out of the 3n. Okay, actually, I shouldn't use XYZ then. C, A, B. Or whenever there are ties, we pick the alphabetically earliest one. Yeah, I want to use CAB instead of ABC. By adjusting the value of n if needed, say to a suitable large prime, we can also guarantee that say that pinwheels never pass through a point while on this lattice. Now by Sperner lemma, there is a small equilateral triangle somewhere in this mesh whose three labels are different. Then the vertex. Sperner's lemma is the thing that says that if you, so okay, let me tell you the story of how I learned Sperner's lemma as a kid, which is that. Also, I might have misspelled Sperner. Someone double check it. Have you solved IMO 2023-6 yet? Yes. Or rather, I read the solution because I was helping write up a solution for it for Math Magazine. Did anyone go to HMMT? Yes, I was there. I gave out a lot of autographs, apparently. Yeah, anyways. Then the vertex with label... Okay, I said the largest one and then pick the alphabetically first one. So... because we see that moving it in a slight way would cause the label to change from A to B or C. Yeah, the way I learned Sperner's lemma is that you imagine you have like 3 people who are trying to like cut a cake or something. Like you have a cake and you need to slice it in some way, where the 3 vertices correspond to like giving it all to one person, and you want to find a mutually agreeable division. And you have this assumption that like, you know, no one would be I don't remember exactly how the story goes, but basically it's like some sort of fair division thing where the things on the sides are obviously unsuitable for one person or something like that. I forget exactly how it goes. Yeah, some rent thing. But yeah, anyways. Cool. Alright, that was not... Hey, okay. I mean, seems good. We cook. What are the intended solutions? Move the pinwheel on a gigantic circle. Okay, well, I'm glad I could contribute a new solution to this. Yeah, I don't know. I figured it was supposed to be some sort of continuity thing, but I had this Sperner's idea for a bit, and I was like, this is too stupid. Like this is too crazy. And then I was like, wait, I don't actually see what goes wrong with it. And then looks like it works. So, good for us. Yeah. All right. For my point. Uh... Yeah, I don't know. Hey. But I don't. Yeah. Okay. Do an minute next. What else was next on the list? Well, I already did Team 5 though. Like, so the thing is, I was grading HMMT Team Run, and I was like, there were like 2 people behind me, and that was the entire grading force for problem 5, and it was very easy to grade because either people found the construction and they wrote the construction, or they didn't, and then it was very obvious that they didn't. Anyways, okay, yeah. For those of you on YouTube, thank you for tuning in. I hope that was mildly entertaining. Wow, Sperner. I haven't seen that in a long time. Take care.